Hi, I'm Bob Pryor, and today I'm talking to you about the unit circle, specifically about definitions of the unit circle and points on the unit circle. It's important to know that actually every circle is a unit circle. A unit circle simply has a radius of length 1 unit. Now, typically, that can be a unit of an inch, or a meter, a yard, or a centimeter. These are all units of length. But we have one new unit of length called a radian. A radian is unique to unit circles. In fact, in general, it is the length of the radius in a circle. And because circles come in different sizes, there is no set length for a radian. It is whatever it needs to be, unique to each circle. For example, each of these circles can be a unit circle, and they all have a radius of 1 radian, but a radian is different in each case. A radian could be 9 millimeters or 1.9 centimeters or 7/8 inches or 2 feet, whatever it needs to be. A radian is 1 radius. That's what you need to know. All right, so let's take a look at the unit circle in the XY plane. Because it's a circle of radius 1, it has this equation x squared plus y squared equals 1. We also know that at every axis, every 90 degrees, we have an angle measure that we can put around the unit circle. 0, 90, 180, 270, and end at 360 once around the unit circle. We're going to be looking at a variety of other angle measures as well. But first of all, let's take a look at the actual ordered pairs at each of these axial points on the x-axis and the y-axis, keeping in mind that the radius is 1 because it's a unit circle. So on the far right x-axis, the point is 1, 0. And on the y-axis, it's 0, 1. In the negative x-axis, it's -1, 0. And on the negative y-axis at 270 degrees, the point is 0, -1. But we also have other angle measures in each quadrant. For example, we have our standard 30, 45, and 60 degree angles in each quadrant. We see it listed here in quadrant 1, but those 3 marks will carry over into quadrants 2, 3, and 4, and there will be angle measures for each one of those marks. The way we develop those angle measures is to consider this pattern of 30, 15, 15, 30. You see, we add 30 degrees to 0, we add 15 degrees, we add 15 more, and then we add 30 more, a total of 90 in one quadrant. From 90, we add 30 degrees and keep that pattern going. We get 120 degrees, add 15, 135. Add 15 more, 150 degrees. Add 30, and we're at 180 degrees. Add 30 again, we now have in quadrant 3, 210 degrees. Add 15, and add 15 again, 225 and 240. We add 30 degrees to get 270, and then we start the pattern all over again. 30, 15, 15, 30. And you can see the numbers as they appear in quadrant 4, all the way to 360. These are numbers you will become very familiar with, these angle measures. In fact, here they are again. I have them a little bit color-coded where you notice the 30 and the 150, 210, and 330 are all in green, the ones that are closest to the x-axis. The ones that are furthest away are the 60, 120, 240, and 300. And we're going to be seeing how they are related to each other. Notice also what's being put on the circle are points, and that's because that's what makes up a circle, are points. And each of those points has an ordered pair, and we're going to be discovering how it is that we can figure out what those ordered pairs are. First, though, let's take a look at angles related to 30 degrees. Of course, we start with 30 degrees in quadrant 1. In quadrant 2, we have 30-degree angle, but it's theta hat that is 30 degrees. And that's 30 degrees less than 180, so actually it's 150 degrees. In quadrant 3, theta hat, again, is 30 degrees, but it's 30 degrees more than 180, so 180 plus 30 is 210. And in quadrant 4, 30 degrees less than 360, almost a full circle, but not quite. 360 minus 30 is 330 degrees. So these angle measures are all related to each other: 30, 150, 210, and 330. Let's do the same thing for angles for 60 degrees. Starting again with 60 degrees in quadrant 1, but notice we're going to just draw a full diameter over into quadrant 3 and then another diameter in quadrants 2 and 4. In quadrant 1, of course, we have 60 degrees. And in quadrants 2, 3, and 4, it's theta hat that is 60 degrees. For each of these, we either add or subtract from 180 or 360, depending on the quadrant. In quadrant 2, we subtract from 180. So 180 minus 60 is 120 degrees. In quadrant 3, we add. It's 60 degrees more than 180. So 180 plus 60, 240 degrees. In quadrant 4, you see we subtract it from 360 degrees. And so all of these angle measures are related to each other: 60, 120, 240, and 300. They're all 60 degrees away from the x-axis. We can do the same thing for 45 degrees. Here we draw the diameters, 45 degrees in quadrant 1, but theta hat is 45 degrees in the other quadrants. And we always compare these to the x-axis: 0 degrees, 180 degrees, 360 degrees. And so we're adding or subtracting 45 compared to, first of all, 180, either subtracting or adding, and then compared to 360, where we subtract 45 degrees. And so it is these angle measures that are now related to each other. We have other angles that are related to 30 degrees, in particular negative angles, and also angles that go around the unit circle more than once. When we come down from the positive x-axis, that's the negative angle direction, and that actually takes us 30 degrees in the negative direction to negative 30 degrees. We go to the negative side close to 180, negative 180, but not quite. We're at negative 150. But if we start at the 0 and go in the negative direction all the way beyond the 180 mark, now we're at negative 210 degrees. And we can even start at the 0 and go all the way around to the first quadrant. And that's one more related angle, 330, except it's in the negative direction, so it's negative 330 degrees. Likewise, we can go around one full circle at 360 and then an extra 30 degrees. So that's 390 degrees total. Or we could go around a full 360 plus an extra 150. And 360 plus 150 is 510 degrees. And these angles are actually related to each other. 510 is coterminal with 150. They terminate in the very same place, both in quadrant 2. Likewise, 390 and 30 are coterminal. So let's take a very specific look at the point in the xy plane at 30 degrees, the actual ordered pair. We'll start by recognizing that there is a point there and that there's a radius that goes to the origin. From there, we'll drop down to the x-axis to draw a right triangle. Some things that we know: of course, that's a 30-degree angle, but also the radius is equal to 1. And the radius, as far as the right triangle is concerned, is the hypotenuse. So now we have a 30, 60, 90 triangle in the xy plane. The shorter leg is half of the hypotenuse, it's 1/2. And the longer leg is square root of 3 times the 1/2, or square root of 3 over 2. Those actually give us our x and y values. X is square root of 3 over 2, and y is 1/2. So that's the ordered pair. Square root of 3 over 2, comma, 1/2. Know this well. Memorize it, or learn how to develop it, just like I did right here. We can go around then the circle in different quadrants so that we can use positive and negative values, but we'll end up, as you'll see, using the same square root of 3 over 2 for x and 1/2 for y. So they're both positive in quadrant 1. But when we go to quadrant 2, now the x is negative. So same numbers, but it's a negative square root of 3 over 2 for x. And the y value is a positive 1/2. At 210 degrees in quadrant 3, they're both negative. Negative square root of 3 over 2, comma, negative 1/2. Likewise, in quadrant 4, and the x is the positive, and that's square root of 3 over 2 and a negative 1/2 for y. We can do the very same thing for 60 degrees. Again, we start at 60 and we draw a radius, and then we're going to draw that right triangle by going to the x-axis. Hypotenuse, well, radius is 1, and again we form a 30, 60, 90. This time the shorter side is 1/2 is on the x-axis, and the longer leg, again, square root of 3 over 2, but it's for the y value. So our ordered pair, the xy, is going to be 1/2, comma, square root of 3 over 2. And we can expand that around the circle in quadrants 2, 3, and 4, remembering the positive and negative in each quadrant. So there we have quadrant 1, both positive, in that order. It's got to be the 1/2 for x, got to come first at 60 degrees. In quadrant 2, at 120 degrees, the x value is negative 1/2, y value is positive square root of 3 over 2. In quadrant 3, they're both negative, and in quadrant 4, the x is positive, but the y is still negative. We do the very same thing for points at 45 degrees. Again, we draw the right triangle, recognize this time that it's a 45, 45, 90 right triangle, hypotenuse of 1, and so the shorter leg, or any leg, is 1 divided by square root of 2, and we rationalize that denominator. And whatever we get for x, in this case, the same for y. They're both square root of 2 over 2. And that's the ordered pair, square root of 2 over 2. Again, considering positives and negatives in different quadrants. Same idea as we saw with 30 degrees and 60 degrees. If you need to pause this video to watch it a little more slowly, it's a good idea to do so. Okay, so let me talk to you about co-terminal angles. They're in the same location on a circle, and they differ by either 360 or a multiple of 360. So considering starting at 0 degrees and going around 1 full revolution, now we're at 360 degrees. But we could go around a second time, an extra 360, and now we've completed 720 degrees total. And we could go on and on with this, adding 360 degrees over and over. Or we can start at 0 and go in the reverse direction, the negative direction, to negative 360 degrees. We could also go around to negative 720 if we needed to. Now let's consider a 60-degree angle in quadrant 1. And what we're going to do is find angles that are co-terminal. That means they terminate in the same location. We do so by going around one full circle, 360, and then an extra 60 degrees. That's 420 degrees total. Or from there, we can go around an additional 360 degrees. Now we're looking at 720 degrees plus 60, which is 780 degrees total. We can also find an angle that's coterminal to 60 by going in the negative direction. So that's like a negative 360 degrees added to 60. That's negative 300 degrees. So here's our task. We're going to identify the ordered pair in the unit circle at each of these angle measures, starting with angle A. Theta is 675 degrees. So let's think about that. It's certainly more than 360, but less than 720. So it's at least one revolution, but not two full revolutions. If we subtract 360, we get 315 degrees, which is a quadrant 4 value, and it's related to 45 degrees. So actually what we do to find the ordered pair here is think about, well, it's in quadrant 4 and it's related to 45 degrees. What's the ordered pair at 45? Radical 2 over 2, comma, radical 2 over 2. But because it's in quadrant 4 with the x being positive and the y negative, 315 degrees gives us square root of 2 over 2 and negative square root of 2 over 2 for y. At 570 degrees, again, it's more than 360, so we'll subtract 360 degrees and get 210 degrees. Now that's a quadrant 3 value. It's a little bit more than 180. In fact, it's 30 degrees more than 180. So that means that it's related to 30 degrees. So if we remember what the 30-degree angle measure is, not the angle measure, but the point at 30 degrees, the ordered pair is square root of 3 over 2 for x and 1/2 for y. Well, that means that in quadrant 3, where both x and y are negative, it'll be the same numbers, but they'll both be negative. And you see the ordered pair right there. They're both negative. Now let's take a look at theta equals negative 240 degrees. This time, we're going to add 360, and you might be able to see that that adds up to 120 degrees, or what you can do is switch the numbers around. A positive 360, a negative 240. When you subtract, that is 120 degrees. Now that's a quadrant 2 value. In fact, it's related to 60 degrees. It's 60 degrees away from 180, the x-axis, the negative x-axis. And that means that we'll want to look at the 60-degree angle and its ordered pair, which is 1/2, comma, square root of 3 over 2. That means in quadrant 2, in which the x is negative and the y is positive, the ordered pair at 120 degrees is negative 1/2, comma, square root of 3 over 2. Well, I hope this has been helpful to you. And I know some of it went pretty fast, so if you want to rewind or pause or go back to see anything, I encourage you to do so. Until next time, it's Bob Pryor signing out.